Welcome back. What we're looking at here is a collet. I don't know what kind of collet it is. I've looked in the machinery's handbook and this particular collet is not listed. They do list quite a few, dozen different types. It's similar to a 3C collet, but it's not a 3C collet because it doesn't measure up as a 3C collet. So I don't know what it is. So I can't order the one that I want. This happens to be a 1/2 inch one. I have them from approximately a 1/16 of an inch in 1/16 increments up to 5/8 for the lathe. And these go directly into the spindle. Now the ones that are missing, which should have come with the lathe, is the Morse Taper 1 adapter for putting dead centres into it, and well, I want a Morse Taper 2, which was not standard equipment on the Holbrook C8 lathe. So I'm making one. There's a couple of things that I'll need to do is get a battery with a light in it. A light with a battery in it, shall I say. So there's a couple of things that I will definitely need to do, and I'll need to cut this diameter here, which is 1 1/4 inches. I'll need to cut these threads here, which are 1 1/4, 28 or something like that, I can't remember what they are, 32. And I'll need to cut this taper, which I haven't got a clue what it is because the collet isn't listed in the machinery's handbook. So I need to figure out what is that taper. There's a couple of things you can do to measure a taper according to the machinery's handbook. One of them is measure this diameter and then measure the diameter at the largest diameter of the taper, and then the distance between the two. Draw 2 circles and then put a line between it, blah blah blah. Yeah, I'm not doing that. There's a couple of other variations in the machinery's handbook for measuring a taper, but what I've decided to do is this. So I have a V-block and a V-block holding clamp. I also have a piece of aluminium as a soft pad. And I shall insert that piece of aluminium, just the aluminium though, not the brass chip or whatever it is on the aluminium. I'll put that here somewhere, clean it up later. So what I want to do is I want to clamp that so it's not on one of the cutouts, but it's on the flat, and then clamp it. And then I want to check it to make sure it's seated. So I'm just going to hold it up to the light and I'm going to look for light in between basically in that gap there. Make sure it's seated properly. That side looks good. And that side looks good, so it looks good. Yeah. Very good. So it's seated correctly. I've stoned that V-block with my precision flat stones. Now I need to measure that angle on the V-block, so I want to get the V-block something like that in a precise manner. Now I know the width of the V-block, and I could just prop that up there, oh, excuse me, on some J-blocks and work that out. But one step better than that, I have a sine bar, which is a known gap, it's 5 inches. and because it's 5 inches, the machinery's handbook works on 5 inches. So I need that parallel to the edge. It's pretty critical that that's parallel to the edge. And I could do many ways of holding it parallel to the edge, but I'm adjusting it and then adjusting the gap with my finger until it's level all the way down. Right, now I need to put my gauge blocks underneath it. So I only have these gauge blocks here, and I like it because it says on here inspection department. So inspection department, but inside, when I get the box open, they say workshop grade. So some inspection department was using workshop grade gauge blocks. And as you can see, it's a very limited set, and we go from 130, I think it's 250, is it? No, it's yeah, sorry, 250, 385, 500, 615, 750, 870, 1 inch, 2 inch, 3 inch, 4 inch. If you worked all those out, you'd realise that there's a mass amount of gaps in that set. Could have done with about 5 or 6 more gauge blocks, and then that could have done most measurements above 100 thou. But it can't. So what do I need to do? Because I already know from doing this before, because I've already done this once, that I need blocks of around about 860 to 865. Now I've got 860 and I've got 865 in this, but I've got nothing in between those two measurements. I want to know exactly what it is, because in those measurements in the machinery's handbook there is around about 7 minutes of degree difference. So the way I've decided to do it is to use my adjustable parallel set. So let's go for it. Let's see what I need. 3/8, which is 375. B is 1/2 inch. C 11/16. D 15/16 to 1 5/8. No, I need this one. C 11/16 C. Now, I've never really used these before, so they're still in their protective wrappers, and I'm not sure if that's the right size I need now. I think that's going to be too big. Let's give it a blast and have a look. So here on my inspection table I have my Mitutoyo micrometer, which was a gift from a person that I bought a lot off of a auction site. When I got to his place, I had a word with him, told him what I was doing, and he gave me this, which is absolutely fantastic. I'm very hesitant to use it because it's the most accurate micrometer I've got, and it needs zeroing. Maybe not. Yeah, I've got some dirt in there. This picks up 10,000ths of an inch very easily. Any dirt in it, it picks up. There we go, zeroed out. Cool. So I need less than 860 basically, so I can adjust these outwards. 850 is there, are we below that? Yes we are. So these will be the parallels that I'm using. Clearly I'm going to have to clean all the grease off. I think my hand is doing a very good job of that. Extremely good job of that. Now I need to set them up. to what I want, and I want 861, 862, 863 and 864 because I wasn't able to measure those, so I'm going to have to set that up. So I have a 545 gauge block here, and it measures, I don't know if you can see that because I can't see in this little lens, in this little camera thingy, and that's 545 exactly. So I know that's 545, I think we'll agree, that's 545. So here is my comparator stand. I think it's locked, I'm not sure exactly how to use it, which you'll probably figure out now. Just undo that, bring it down, and we need 8, so I'll bring that down, no I'm not. So that's 7th thou, I believe. 7th thou, 5th thou, 4th thou, 4th thou, 5th thou, 3th thou, 5, 4, 4, 5, 4. Right, for the benefit of it, we'll say that's 5th thou. So it's 5th thou before 0. I've set that up pretty well. I think you can do some kind of micro adjustment on this, I'm not sure. Oh, way up. 3th thou. 3th thou. 3th thou. 3th thou. 2, oh dear. 2. 2. Okay, we'll say it's 2th thou. 3th thou then. 3. 3. 1. 3. 3. 2. Alright, 2th thou then, we'll say 2. So I've got to add 547 thou to this measurement. It's 267. I'm going to do the maths off screen because this is going to be like the crappiest math exam, the crappiest maths tutorial ever. With the calculator. Okay, that was tenths that we were reading on that, so that's 2/10 above 0. So it's not a massive difference. And I'm looking for 0.861. So I need to have that height there, which is reading at 0.2683. I need that to be reading 0.3158. 0.3518. Oh dear. And these parallels are brand new and tight. Really annoying to use. There we go, I've got them. Really annoying. That's 400. I need 3158. Four eight. Right, I'm going to tighten them down at that, and we'll see if it's any good. Get my screwdriver out. Remove that. Try not to move them. lock it up. It's bound to go down a couple of tenths when you lock it up on the dovetail. So that's locked up now, and let's see what we get. Yeah, that's moved no end. 3126. That was 3158, I'm sure it was. It's gone down to 3126. This could take a while. This could take a long while. So if that's gone down 33 thou, we need to go to 315, 316, 317, 317, 7. Let's tighten them up at that and see what happens. And that stayed exactly where it was. It is typical, is it not? That is way mega typical, that is. It's just like a joke. I've undone them and they still stay about the same. Well, too far. So, about there. About there. So just nipped, not too tight. Sweet. Okay, so that's 1/10 over. I think we can handle 1/10 over. Next is this. You set that out. I'm pretty happy with that. Be careful, don't want to touch. Put that back in. Still at 2/10. That's good. So we haven't moved anything with the gauge. So then we will just wipe any dust off of this, and we'll bring the sine bar in, and we will rest the sine bar on that, and everything will fall off. Oh dear, I did have a clamp on this when I did it last time. I just thought there's enough on that I ain't gonna have to worry about it. I just lifted it a bit too far and overcome with the gravity. Fortunately it was close to the end. And the end of the collet hit things. I think I'll put a bit of cardboard or paper down there in case all this happens again. My word. Oh, let's turn the Digimatic off and we'll bring the surface gauge in. So what I'm going to do is I'm going to hunt for the high spot, and well, to be honest with you, I don't think hunting for the high spot right now is what's going to be happening. I think getting that slit away from the top is what's going to be happening, and getting the slit in the centre at the bottom. Yeah, that's better. And check for the light again, make sure I've got it seated. That side's good. And that side's good. Okay, and then we'll line it up again. Try to. Alright. And then what I'm doing is I'm going to bring my gauge in. Maybe. That's a bit of a big ask for that, that is. Try and do it without knocking everything off. There we go. Look for a 0 and look for the height. High is at 1.2 right there, bring it back to 0. Is it 0? Look for the high again. 5/10 over. So that's 2/10 over 0 there, and there is 1/10 over 0. So it was a good guess, that was. Maybe 1/10 over, 2/10 over, 3/10 over, 3/10 over, 1/10 over, 3/10 over, 3/10 over, 2.5 over, 3/10 over. I'd say that's bang on. So I'm just reading the dial, which I know you can't see there, but you can see the general idea of what I've done there. So I know that was 861 thou, because there is my calculation. I don't know if you can see that. I ain't got a clue whether you can see it. There we go, I can definitely see that. 0.861 minus 0.5452, that's the 2 thousandths, the 2/10,000ths on top, equals 3158. We'll just double check that stack inside there. Try not to let everything fall off. We'll see what it was. I know it's close to that. Turn that back on again. Bring that up. And down to there. Well, something's gone wrong. Yep, something's gone wrong. Now it's 1 thou. Yeah, I think this gauge block has cooled down because I was holding it for a small bit of time. So that's 1/10 over 545. And that's 3154. 3158. We'll take 1 off of that because we were working out at 2. 3157. So that's 3/10 over. That's close enough. I would say that I need to work it out at that measurement, which is 861. So let's do that. So here is my 21st edition Machinery's Handbook, and we're looking in there, and I'll look for the measurement. So there's pages and pages of these. It starts at 0 degrees at the top of the page, and the measurement on a 5-inch. This is the. I should explain. This is constants for setting a 5-inch sine bar. And that was a 5-inch sine bar I used, and I had a measurement of 0.861. So something close to 0.861 is 8611. So this is 9 degrees and 55 minutes exactly. But I'm only going to have to cut one side of it, so I'm just doing the side that I measured, obviously, and that will work out that the two sides together will work to a combined angle of 20 degrees around about. But anyway, I'm going to have to do that, so I need now to know how much taper per foot or per centimetre or per inch that I've got to set the compound to, because that's the easiest way to set the compound. So let's go and have a look at setting the compound on the lathe to cut this angle. So fortunately on my lathe, the side of the compound is supposedly flat and square. And okay, I've done some complex calculations and that's what I come up with, so that's what I'm going with. Side A should be 0.3506. That better be right. So I'm going to put the compound back to where I think it should be, because I think it was around about that before I moved it. And we'll try to tap it somehow. Got something brass here. No. Got copper, but I'm going to hit everything if I do this. And that's 9.5 degrees, it's got to be 9.95. That's 9.9. And that's the fanny's hair off of, or a gnat's cock off of 10 degrees, so that should be bang on. Let's bring this up to 2 centimetres, and that should be 0.3, so we're just below the 0, just above the 0, and we're on a 0, and we're on a 0. Okay, let's bring this up to 2. And that is 0.331, and we want 351 approximately, so we need to go a little bit more on the angular dangler there. Oh, let's hit the lathe base a little bit. It's always a good idea just to give it a quick tap, like, you know, just in case it wanted one. So I've basically gone half the amount of what I need to, because when I come back to 0 I'm going to have to re-zero it. Let's come back to 0, and let's go back to 0 then. Zero, so let's re-zero that. Well, providing I've done my calculations right, I am now 1/100th out. So I think we'll just take that out, just that little 1/100th there. And loop, and we'll nip it up at that. I don't think nipping it up at that will make too much of a... I won't move it at all. No, I haven't moved it at all, cool. Back to 0. And we're on 0, okay. Yeah, that's close enough. It's just a gnat's fanny over 50, which is close enough. That's really close. Properly close. Alrighty, I've got me orifice blued up. I'm trying to adjust my camera so it's good. So, I don't know if you can see that, possibly, orifice blued up. Yeah, all good. And I haven't done this yet, or maybe I have. Just wipe that off, because you're not going to believe I've done that. Wipe it off. Wipe it off. Dry it off now. I use a damp rag. That was a bit stupid. Anyway, I've been on the Clark mini mill and I have inserted a keyway 3/16. I missed it by 1/1000, converting from metric to or imperial to metric and back again, and it turned out 126 thousandths, so I'm quite happy with that. And I'm extremely happy with this. So it goes in, and there's a little bit of turn. There's a bit of play on the key because the key's about worn out. There's a bit of side by side there, and look at that. I am extremely happy with that. Considering I measured that using that sine bar, I've cut that using the compound, and I've got it that good. That good. It's that good. I'm really happy with that. Like, absolutely exceptional. Look at it. Look at it. Look. Look at that. It's like, get in there. It's a picture I nicked to the side of the shaft here with the threading tool. There's a bit of deburring to do. It keeps on cutting my fingers a little bit, but yes, that is in. Get in there. So the draw bar will go on that. Then I've just got to pop a hole through the centre, cut a Morse taper 2 into it, and then I have a Morse taper 2 adapter. So then I can run the boring head and make the drilling attachment. So there we have it. Fully installed. And I've just turned it down to a nominal imperial size of 1 inch and 23/64, because that was the next size down, and it's half a thou under that. Half a thou. Good grief. So now I need to drill a hole in it. So there we are, we're all in position. Just about, so let's put a starting position in the centre, hopefully. Very light on the centre. Notice the instant stop with the electronic brake on there now. We've gone in pretty deep in there now. Yeah, I've gone in pretty deep in that now. And that's with a hand sharpened by me drill. Let's see if we can zoom in on that. There now. Can we get on that? There we go. So that was sharpened by me. Offhand on the hand grinder. I'll quite get it's pretty sweet, to be fair. I'll just thin the webs on the inside a little bit like you do, and it drills in beautifully. It's only a 5mm I think, but it's my new 5mm shortened drill. It's tin coated and drills holes. Pretty much what you want a drill to do, really, isn't it? That's it. Can't go any deeper. I need to go way deeper than that. I can't go any deeper. Deepness is not happening with that drill. And the only other drill I've got which is similar to that looks nasty. Very seriously nasty. And I can't find a wedge to get it out with. So we'll pause and do all that. Okay, I've got a longer 9/16 drill bit. This still might not do the job. Backup plan is a 14mm and bore it out. Of course I've got the other piece of material and we are just about through, so these are approximately the same kind of length, so yeah. We'll leave pushing the hole all the way through until right at the end after I've cut all the taper and everything. So we'll do it to 11 for clearance for M10. Now I've got to set up for boring the taper, which will mean getting the taper attachment up and running, so I need to clean out this slot. Get the vacuum out and vacuum off all this round here and get the lead nut securing thing. Alright, this is not an ideal solution. The compound is set to the 9 degrees, whatever it is, and the thing, taper attachment, is set to another. So we need to bring that in a bit, and that should be missing it now. But we still have adjustment and I think it will be enough. Time will tell. Lathe into reverse. Lathe out of back gear. Lathe slowed down. 14 Hertz. And you know what? I don't think I need it in reverse, I think I want it in forwards. Yep, that's better. You really shouldn't do what I'm about to do. But I have no choice right now because I'm stupid. Right, so I want, this is an extremely blunt piece of emery cloth, like properly blunt. I just want the front of that deburring. That should be it. That should have took that burr off. If it has or not. Well, we'll see how good it is. It's been reamed, so it should be half decent in there. So I'll deburr the back of it. There's an 11mm hole through it. The Morse taper 2. You can see the land down the bottom. There's a section in there which is actually 14mm, it should be 14.5mm or thereabouts, where the tang of a Morse taper 2 would go in there. I think it's in there, yeah. Yeah, so there's a section down there which is around about, well, it's quite long actually, to be fair, but it's long enough for a tang. And there should be enough meat here, it hasn't broken through into the keyway. That's the reason why I made it this long for this one. I am seriously thinking about making the Morse taper 1 adapter, which I'm just about to make, but the same length as a normal collet. So draw a bolt through the back, holding in your Morse taper 2 bit. Just going to have to clean all that out now. Yep, give that a good cleaning. Deburr this end. And try something Morse taper in it, put it back in and see if it indicates true. So I'm a bit stupid. I just put it into the, I just put it in, I can't get it back out again. I've got to find a bolt. But there we go. Now we're looking. So that's what it's going to look like. Let's just do the drawbar up. Might better get it out then. I don't know if you notice I've turned the lathe off now, so I'm packing up for the evening. It is 7:10. I'm in my kitchen. So I now have a boring head in the lathe, which is really smooth moving now. I've cleaned it up. Although it's going forwards and backwards, there ain't no rock in it, man. Just a little bit that way and tighten the gives up a little bit more. It's beautiful. I've already used it twice now. I'm happy with this boring head. So this boring head now has got to take a divot out of that. So basically it's going to run across that like that, and it's going to take a cuts out of that. You can't really see that, can you? But yeah, it's going to take a divot out of that, as if you wanted this to clamp onto that, like that, and hug it nicely. Now I've got to do the machining on this first before I take the divot out of it. So there's going to be a concaved rebate in the centre of that, and then there's going to be a flat down here, so there's going to be a squared cut down there. It's going to be drilled and tapped, and there's going to be another one on this side, another square cut out of that side, and that's going to be drilled and tapped. So the two drill plates can be screwed to either side of that, so the drilling attachment can go onto it. There's got to be a underside, there's got to be a hole put into it, and that's got to be 454, I think it is, to go over the peg for the tool post. Then it's got to be slotted here, and then it's got to have a drill hole corresponding to that slot, so you can put a nut in the slot and the stud will go up through that hole and the nut will hold this down. Then there's another one corresponding to that 180 degrees away from that, so another slot in there, another hole in there corresponding to that slot, so the stud can go through that hole and the nut can be put in where the slot is. And that will be that done. It's been sitting there for about 2 months now, just sitting there going, look at me, you could do me. There we go. So that's just pushed in gently, that should come out, yeah. So that's pushed in a bit harder and it still comes out, and now that's in like that. And can I get it out now? No, I cannot get it out! Can't knock it out now. So literally the slightest little dip, and it takes some getting out. I'm not blowing it up. I used a reamer. If the reamer's out, the reamer's out. If the reamer's right, the reamer's right. But it is reamed. With a Morse Taper 2 reamer, it should be pretty much spectacular. Sorted. So again, I'll be able to get that out, not a problem. I'm squeezing it, I'll be able to get that out. But this, so you can see there was no effort there, and it will not come out. Oh! So if it was going to come out easily, I'm pushing against the back. So that one wasn't quite as tight as it was before, but as you can imagine with a drawbar in it, it ain't coming out. It should be concentric. But that's for another video. I don't think I need to be doing that. I might do that. Let's just quickly do that, eh? Alright, so she's in. Let's see how concentric this bit here is and that bit there. So this being the low, so it's not even the, if it was in line with the, yeah, unfortunately because it's not a 4-jaw, it's not going to allow it to do it. That's the problem. Now since I'm getting the same 5 thou here as I am here, it's obviously all the problem is in this here. So I might just try another Morse Taper 2 thing in here and see if it's got a 5 thou run out. Oh my word. Oh my word. See if the tang will fit in. I don't think it will. I don't think the tang will fit in. Yeah, well. Right, so this is going to be like a test bar. This is a It's turned down. It's a Morse taper 2 to Morse taper 1 adapter. And someone's turned this one down. Great. Well, it's not great, it's a bit annoying. Obviously the word great in England means shite. We like to use the negative positive words. Positive negative words, shall I say. Right, have we got half a thou? Sorry, half a thou. No. I'll zoom in on that. So it looks like around about 5/10 have run out right there. So not the 5 thou, we've got 5/10 here. So that's pretty good. And what about right out here? Right at the extremities. You can't see that now. That's always handy. Just zoom out a little bit, you'll be able to see it. There you go. You can see it there now. Yeah, we've got about 2 thou at that kind of. But we don't know how well this was machined. And now I can't get that out because that's going to be impossible to get out. But yeah, we've not got 5 thou here, so definitely their engineering's crap. Whether it be China or India, I don't know who made that one in particular. Came from eBay, so it's probably going to be a Chinese one, but they are getting a lot of Indian stuff on there now, and it is terrible. As we've seen with my little rotary table, which isn't quite finished, which there's another thing I can get finished now. Cool. So I'm happy with the tolerance on mine. Half a thou here, and the taper might be a little bit skew whiffy. All of which I can sort with my reamers. Thank you very much for watching me mess about on my lathe.